This is part 22 of the basic Python programming tutorial for Blender users. And in this lesson we'll continue with this vector class here. And instead of just taking the components and adding them together, we're going to take a vector and find its components so we can pass them into this routine and then add them together. And so let's just take a look at this real quick. We won't spend long on the mathematics here, but if you're really rusty with trigonometry, then you might want to take a look at my math tutorials, because I have quite a bit of math tutorials on algebra, trig, things of that nature, in case you're rusty, but you might figure it out from here anyway. So let's say we'll start with something simple. Say we have a unit circle. Let's see if I can draw a freehand circle. It's kind of hard to draw a circle with a mouse, I assure you. Let's see, I already see I'm messing it up. That's terrible. That's a terrible circle. Well, anyway, here's our unit circle, which means that it has a distance of 1, and here would be -1 over here, and here's -1 down here, and here's +1 up here. There's a 1, and this is our y-axis, and here's our x-axis, like this. So a unit circle means that it has a radius of 1. So anything from here, let's say I draw a vector at a 45-degree angle from here to here, this is going to have a radial distance of 1. And this is going to be a 45-degree angle. And a lot of times your vectors may be specified this way. Or maybe it's not just a vector that's specified that way, but maybe it's how you're saying, yeah, it's over in that direction 1 mile at a 45-degree. You know, instead of saying, oh yeah, you go down the block this far and then up the block this far, you just go that distance of, say, 1 mile. You know, if this was specified in miles or something like that. But this would be 1. So say you want to find out, when you, in the previous lesson, we knew the components of a vector, like this, 1 and 3, and we added those to another component. But in this case, my vector is indicated by an angle and a length, or an angle and a magnitude. All right. But I don't know the components. I don't know the XY component. And in fact, if we look at our fountain design here, when we were specifying these locations, we were doing it with radian angles of measurement and radial distances, but that didn't give me the individual XY locations here, which maybe I want. Maybe I want to add an object or a particle system or something at that location, maybe to go out like this from this location. I want to know what that XY component is at a location. Well, vectors are a way that allow us to get components. So what we want to be able to do is we want to be able to find these components, the y component that's associated with this vector and the x component, because it's really no different than saying I'm traveling this far to here and then I'm traveling this far to here, and you get to the same location. Alright, so basically it's a way where, you know, you can extract the components from this vector, the x and the y components, and then once we have those x and y components, then we can come back in here and we can add them together. So given a vector that has an angle and a radial distance, or a length, then we can get the x and y components and we'll add them together. We'll implement that in code as well. So we'll start with this most basic case, just kind of a root. We'll work in reverse a little bit. The formula for getting these, in case you're not familiar, is you can get the x value is equal to the radial distance, r, that's an r, times the cosine of theta. Cosine of theta, here like this, theta being this angle here, 45 degrees from the x-axis, going counterclockwise like that. And then the y component is equal to the radial distance times the sine of theta. So this is really straightforward, because in this case our radial distance is just 1. So if our radial distance was longer, then we'd have to use a larger value of r in here. So in this case, really the x value just becomes x is equal to the cosine of theta and y is equal to sine of theta. So let's get the first component for x. Let's get this x value here. And so we need the cosine of theta. Theta is 45 degrees, so you enter in 45 degrees onto your calculator. Like that. Make sure it's in degree mode, because I've specified things in degrees, not in radians in this case. And so I press the cosine button, and it really becomes, so the cosine of 45 degrees is equal to, and you'll see the result is 0.707. Right? And what's that telling me is that x is equal to the cosine of theta, or x is equal to 0.707. So my x component is 0.707. And in the similar value for the y value, use the sine function to get the y component. So the sine of 45 degrees, if you enter that in, enter in 45 and then press the sine button, sine of 45 degrees, it also happens to be equal to 0.707. So trigonometric functions are circular functions, so they can give you points along the circle. And if it's a larger circle like that, you just adjust it by changing the radial distance and multiplying it by the longer magnitude of your vector, whatever it happens to be, or the longer radial distance. So then y in this case is also 0.707. So then I have the x and y components. Well, I need those components because remember, when you want to add vectors together, you have to add the individual components together. So we had to extract the components of the vector. Alright, so knowing that, what we're going to do is we're going to add two different vectors given different angles. Alright, so let's go back into the code. And in here we were using this one method. This is our add vector method. And then we're going to do another method. And we'll call this extract components. And we won't pass anything into it. We'll just give it a value for starters. We'll say vector 1 distance. We'll call it vector 1 magnitude, because that's really the formal term, is equal to 1, and vector 1 angle is equal to 45, and then vector 2 magnitude is equal to 30, and vector 2 angle, nope, I'm doing it the other way. Vector 1, we'll just do the same thing. Vector 1 magnitude, same radial distance, and vector 1 angle is equal to 30 degrees. Alright, so we have these two, and within those two, what I want to do is, no, just do this. Better get the components of the vector, of the vectors, and add the components of the vectors, like this. Alright, and so down in here, we're still extracting these things out. So we have to have, are we importing? Oh yeah, we're already importing sine and cosine up there. So then, well, we'll just say x1 is equal to the cosine of v1 angle. And best thing to do is, I always like to do it like this, is put things in floating point format like that. If I'm working with a floating point number, I like to work in floating point. That way it keeps, it reminds me of what I'm doing. Alright, so the v1 angle, cosine of the vector 1 angle is x1, and then y1 is going to be the sine of the vector 1 angle, and x2 is equal to the cosine of the vector 2 angle, and y2 is equal to the sine of the vector 2 angle, like that. So then we have these components of this, because, well, we could say r, but in fact that'd be better. We'll just say we'll do rd for radial distance. I'll just say radial distance, and I'll just call rd, and rd is equal to 1.0, because really the formula is r times the cosine of that. So I'm going to rd times like this, and rd times, that way if you want to go change the the radial distance, you can just do it like that, RD times. Okay, so so this should give us x1, y1, x2, and y2. And then, well, wait a second. Since we already have those values, then from extract components, all right, and then what we want to do is, instead of calling the myvectors.add directly, let's just do it this way. Copy that, we'll comment this out, but we'll call it from the extract components method, myvectors.add x1, y1, x2, y2. Like that. So then, since we're extracting the components, and then we're going to call myvectors.extract components, which has no arguments. It's, oh no, it does have arguments. Is going to have extract components is going to have, well, it doesn't. We actually specifying the angle within there. So okay, so just like that. So what happens is we've defined this new method which extracts the components of the vectors based on the angle and the radial distance, which I'm just giving in right now. And then within there it calls this method within the vector, within this class, which adds them together. So let's see, well, let's run it. See how many errors we get. Error. Okay, error. There's always an error. Let's see what I did. Extract components. Extract components, line 43. What are you talking about? Extract components. Oh, how about this? How about we define it? Okay. Well, let's save that real quick. Save it and then run it. Do we get an error that time? No. But now it says resultant is 0.679 for x and -137 for y. So it gives us a, see if we did this right, x2, and there's sine and the cosine, and then we add x1 and x2 together, and x1 and x2, so these should both be positive. That'd be a 45-degree angle. Oh, RD, yeah, RD is 1 times the cosine of the V1 angle, the sine of the V2 angle, and then we add x1, y1 into x2, y2. So let's do this. Let's in here just print x1, y1, x2, y2, and see what our components actually are. And run the script. So it says our components are 0.525, 0.0. Oh, easy. I see the problem. So this is another real good reason. It's so obvious. It's just as, so the problem is angles. Well, when you take the cosine, you're not using degrees. You're using radians. So we really need to specify our angles as radians. So this is going to be, we're just going to approximate it 0.785 and 30 degrees. So we'll just say, no, we didn't know it was pi divided by 6. Heck, let's do this way. Pi divided by 4. Alright, so now our angles are expressed in terms of radians. So this is, I'll give you this. So that's a 45-degree angle. And this is a pi over 6 is going to be a 60-degree angle. Like that. Alright, so now let's run it. And let's see if that works. So our components, alright, so there is our x1, 0.707, there's y1, and then for and then for x2 is 0.866, that looks correct, and for y2 0.499999, it's really 0.5 is what you usually see, but since so that's it. And then if that would be, so x1 would be added to x2, so 0.707 plus 0.866 would be approximately 1.57, right? And then x2 is, y1 0.707 plus y2 is equal to 1.2. So basically, in that case, we've added the components of the vector together, and we've called it just the one now, extract components. And of course, you know the next step in the process. Well, since this tutorial is, I'll let you work on that. Maybe I'll just fill it in the next time around. Then what we want to be able to do is you want to pass in your angle and your radial distance into this routine. All right. Well, since it's a long extracted lesson, I think you get the idea though, right? All right, well, that's it for this lesson, and I'll see you in the next lesson.